Let's make it a little bit more clear, and if you want, a certain level of abstraction. So the problem to be solved is agreement. So we have to agree on what is the permanent record, for example, what is the history that should be audited, what is that we can do data mining on so that we can extract useful information. Agreement is key. And of course you can say, if that's my own data, there is nothing to agree on. I have my data and I can mine them and I can make decisions about them. But clearly, your data is just a very small fraction of what is out there. And there is clearly much bigger value in actually performing these actions of mining and management at a scale which goes across boundaries of organizations that hold data. So the challenge that will have to agree on what they have to do, they have different incentives about what to agree on, and this is where things get more complicated, exactly because of this class of incentives between the participants in these systems. So now you can ask, okay, I mean, all that is fine and interesting, but is that really new? These are the type of problems that in computer science have been around for a long time. Actually, maybe some of you have heard the term of Byzantine agreement, and it's been around since the 80s. And if you want, is one of these quintessential problems of information systems. Like such a beautiful problem. It's not a math problem, it's like a pure CS problem. A problem which has this elegance of being so easy to state, but so hard to solve. It's one of those problems that make computer science beautiful as a science. And it's been around for a long time. So, nevertheless, it remained essentially in the theoretical domain. It was this nice, interesting theoretical problem that there are these very complicated protocols that solve it, but essentially none of them being implemented. And furthermore, and that's also quite interesting, it was almost exclusively considered in a setting where actors were predetermined and known to each other. And that's like an inherent flaw of this traditional approach of thinking about the problem. Because the actors that are actually engaged to solve the problems, they are themselves a matter of agreement. So there is this circularity issue which somehow is not recognized in, if you want, the vast literature of decentralized protocols for Byzantine agreement that we know in computer science. So this blockchain type of agreement, like if you want the instance of agreement that blockchain solves, was essentially ignored by the CS community till 2009. And that's like quite fascinating, I think, also from a pure science point of view, that such a fundamental question was missed from the mainstream CS community, the mainstream CS research community, till 2009, when the Bitcoin client was proposed. And the problem was started to gain some traction, but not in theory of computer science cycles, but rather in cycles from developers, hackers that got excited about the Bitcoin system and started to use it, recognizing that it was actually solving a problem which is quite fundamental, but without actually being able to express why it's so fundamental, because they lacked the formal training that you would expect to find from someone that is studying distributed systems. So, in a nutshell, why blockchain works? So, now if you want, you can structure the history. You can take this like very simple picture and say history is structured as a blockchain. The left is the oldest blocks and the most recent is the latest blocks. And decentralization has this negative outcome that there are many alternative histories, many alternative blockchains that coexist and might be pursued by different parts of the system as the system evolves in a decentralized fashion. Nevertheless, the protocol that implements a blockchain imposes a chain selection rule that, together with certain cryptographic components that the protocol has, makes it economically infeasible for a splinter coalition to revert history to an alternate, preferable chain. So this is the fundamental technique, if you want, the fundamental method that is behind these protocols and why they work. So this gives you like a glimpse of what is this domain and why these questions are interesting for a pure computer science point of view. So now we can go a little bit to what happened afterwards. So in 2009, as I mentioned, Bitcoin emerged and gave this paradigm of solving this blockchain consensus. And after that, there were many other systems that were proposed and explored alternatives, if you want, modes of being decentralized. Right now, together with Bitcoin, which you see on the right, there's a lot of other systems and organizations that are exploring this space. And there are many different ways that people have tried to map this terrain. Like a common one that maybe some of you have seen is like this distinction between permission and permissionless type of consensus systems. And I should say both of them are here to play a role in the way that this technology emerges and evolves. So, okay. That might be interesting, let's say from a CS point of view, from an informatics perspective. These are interesting points perhaps to be made, and possibly there are some good number of papers to write in the conferences that we do research in computer science like to submit papers to. But what about applications? How are these protocols really matter, if they matter at all, in the real world? So actually, this is the part that has been actually the one that gained the most traction first. It was not the research conference in computer science that embraced this new technology. It was actually an